Wet weather to return to the central California interior by this weekend. A pair of Pacific weather systems will arrive late this week. The first will move into central California Thursday night with periods of rain developing, continuing into Friday.
A typical winter pattern in California is that we'll see anywhere from 4 to 7 major storms. That's a typical winter weather pattern. You know, we've been under a ridge of high pressure here for the past, few days, and it's been warm and, almost borderline spring-like conditions. And so now the cold air is reloading out over the eastern Pacific, and it's going to bring another big system. So we'll see temperatures coming back down and snow levels dropping. If you're going to be out there Friday, you're going to be getting wet. Now the question is it going to be rain or is it going to be snow? So we come back over here and we take a look. It says here around 4,800 feet we're expecting snow. For points 4,800 feet and above we're expecting snow.
So here we are, standing at the boundary of Yosemite National Park. We've got the Merced River flowing down here next to us, and on the other side, Highway 140, and up the road is the Arch Rock entrance station. We've got some rain. It's the beginning of a big storm. It's supposed to rain and snow all day. And we've got a temperature of 46 degrees. And we are here at 2,126 feet. We've got a benchmark nearby that verifies that. So we're going to head up the road and see where we can find rain turning to snow. In some strict terms, snowline is actually the elevation at which snow stays year-round. And then you have a seasonal snow line, and that's the line at which snow can be expected to be in the winter time. And then you have the snow line that can happen in a certain storm, which is extremely variable over time and space in each individual storm. That transition is what we are chasing. We're trying to find out in this storm, on this day and this hour, where on this mountain is that transition happening. So here we are at Tunnel View Lookout, a very popular place to come and see an excellent view of the valley, which you can see here. It's about 4,400 feet in elevation, and our thermometer said 37 degrees. So 37 degrees, it's getting colder and it's still raining. We seem to have found the lower end of the transition zone here. It's the very first sign of snow happening at 5,000 feet, and it continues to transition just all around us right here. Here we are on Glacier Point Road, headed up towards Badger Pass. We're at about 6,200 feet in elevation, and it's 30 degrees out, and it's definitely snowing. It was an interesting experience driving up the road from 5,000 feet. Maybe at 5,800 feet was when we had snow on the road and we needed to drive much differently and people were putting on chains. So it's an interesting transition from 5,000 to 5,800 feet, I would say, was the transition from where snow began to where it was full snowstorm.
So the average snow line, to the best of our ability to estimate, is about 5,700 feet in Yosemite. If the snow line is at 5,700 feet, that means snow is falling on approximately 90% of the park, and about 10% of the park is receiving rain. The park's topography is such that the majority of the landscape lies between 7,000 and 9,000 feet, and right now all of that area receives snow during a typical storm.
The snow line in the Sierra Nevada is really important for us to understand. Is it shifting? We need to know. There's some variability from year to year, just as there's variability from storm to storm. What we want to know is there a trend happening over many years where we're seeing it creep upward?
And one of the concerns is, as the climate warms and that snow line goes up, a significant portion of the park will begin to receive rain rather than snow, and that has a number of effects.
If you get snow, then it has a tendency to run off more slowly in the springtime. as opposed to if you get a very heavy rain event at the higher elevations, it's going to run off immediately.
An extreme example are what folks refer to as rain on snow events, when the snow line will go all the way up to 10,000 feet and above. And for a landscape like Yosemite, that means 95% of the park is actually receiving rain. And when that much area is receiving rain at the intensity that we normally get, which can be 3 to 5 inches in 24 hours, that's a significant amount of water, and it's moving rapidly into the streams and down into the main channels, such as the Merced.
On January 1st, 1997, Yosemite National Park experienced its worst flood in 42 years. A forceful tropical storm dumped rain onto a deep snowpack, melting snow and sending torrents of water to the park's lower elevations. Roads were undercut by erosive currents, leaving asphalt surfaces with no support underneath. Thousands of feet of rock retaining wall and road shoulder were ripped away. In some places, entire sections of road were washed out.
So if you look behind us, you see Pohono Bridge. In the 1997 flood, Pohono Bridge was completely covered in water. The Merced River here is currently at about 180 cubic feet per second. That's how much water is moving past any given point. That's the volume. In the 1997 flood, it was over 24,000 CFS. So for reference, this is 180, that was 24,000. It's the biggest flood on record in Yosemite National Park on the Merced River. So here we are at Badger Pass, 7,200 feet, and it is 29 degrees is what our thermometer said. And it is snowing, there's no question. Constant, steady snowstorm happening all around us. This experiment can help us understand one of the main reasons why the ecosystems in the Sierra Nevada are so diverse. Because we have variable temperatures, we have this variation that's created just by a change in elevation, just by availability of water, just by temperature regime. How warm is it, how cold is it? It's interesting because I have studied snow and rain and the transition zone and tried to understand how those things are significant hydrologically, but I've never chased the snow line this way, where I've actually taken a journey up the mountain to find out where is it actually happening today. So quantifying that has been really exciting. It's been very, very interesting.